They've been traditionally green because that's what CRTs do best, is create green images. But as it turns out, green is actually pretty visible through a HUD. Some of the other colors out there are much harder to see, but the HUDs we're talking about that we're involved in are full colors, so you can make it any color you want, but you'll visually see that some colors are just harder to see against the bright sky than others. The second gen and LED light source, the Epic Optics HUD we have down there is a laser-driven type of HUD through a LCD screen. It bounced off some mirrors into combining glass. Then the third gen is optical waveguides or laser to produce an image directly in the combining glass. I think the Boeing HUDs most folks have in the 737 or 787 use that type of technology. And then the displays that we have in our micro OLEDs and the AR glasses are actually very different. We'll talk a little more about that later. So the project goals of our Fly on Speed project is multi-platform. The software we create is shareware. It's available on our website. We can interface into about 15 or 20 different types of general aviation experimental world displays, from the eye-level types of displays, the bomb and what all, Stratix, G3X, Dynon, MGL, and some other systems. And we have it designed in such a way as new technology comes along, you can write a interface into our software, and you suddenly can add a new system in to be able to get displayed. Software is available through GitHub and our website, and so we have two versions. One has a software image that you download and write into a Raspberry Pi micro SD card, and then our Gen 3 software, like I call it, actually generates a tool that allows you to build your own HUD display and fiddle with the way it interfaces. You can play back as you develop the display that you want to see. You can play back a recorded data file. And so as you are designing your HUD, you can see exactly how it's working with the playback data that you put in there. And the big goal is to make it affordable, but technologically cutting edge as best we can do. Trying to avoid a $400,000 F-35 type of HUD. We feel the market in the experimental world would be limited if you tried to pass that on. And the F-35 helmet is already pretty much dated. Pretty old technology these days. So we've been working on this software since 2018. We have a number of folks that share their time and effort. My son is the primary programmer for it, Chris Jones. He's a private software developer, so he hangs out at home, has a hangar, has the systems installed in an RV6 and a mall. And then, along with myself and our whole Fly on Speed team, but we've used a lot of help from other folks, and we continue to be involved, and we are always looking for new folks to be involved who would like to help with this. We have one guy lately who just built the interface to allow our HUD to run in some of the simulators. To install the software for a simple home display testing, you need a Raspberry Pi, a keyboard, and a monitor. So How many folks here are familiar with Raspberry Pi computers? Good. I would say that's over half. But the Raspberry Pi is kind of a Linux-based computer, originally built, or still I guess being built in the UK and supported by a worldwide folks, a lot of brilliant folks out there writing software for it, used in probably thousands of schools and what all, and has a tremendous user base. And one of the beauties of it is through the years, when we first started this project, we had a Raspberry Pi Zero, and so that lasted for about a month before we realized that was not going to hack it. So then we moved into a Raspberry Pi 3, and then into a Raspberry Pi 4, and now using Raspberry Pi 5. But it's all essentially the same software that has evolved over time. Now our AOA system we have down there, we wrote that for a some custom ESP32 chips, and Teamsy, I guess Teamsy. And so during COVID, they dropped that chip. The company did, and our software is not compatible with any of the new chips. So we're having to build a new system, move the software over to it. But the beauty of our HUD is that as Raspberry comes out with newer, more powerful chips or computers, it's just a couple hours and your software is up and running on the next generation system. So that's a big plus. As we know that a lot of folks with early ephyses, all your interfaces and stuff are just about worthless when it comes to some of the newer technology that's out there right now. So I'm trying to avoid that as much as possible. So anyway, if you have a Raspberry Pi 5 or a 4 would work too. You can download our software, stick it in there, playback, and run some of our playback files and see how the HUD works and how you can interface with it or change it as need be. So install our HUD system in your aircraft. Different ways we have of doing this. What you see here is a Raspberry Pi. In my RV8, I use a Heptic Optics HUD. I have a little gun camera, which is an FPV HUD camera. I think it's called first person FPV, first person visual. So anyway, there are some beautiful technology in these little cameras, and built a mounting bracket that drops and hangs onto the front of the HUD. But most of the FPV cameras have wide angle lenses. And a HUD, you want it focused near infinity. So it took me a long time of going through probably 30 different lenses that you can collect for these types of cameras. It has to be a telephoto lens to work through the HUD. And finally got it to where it works. So anyway, then feed the video into a little a digital video recorder, and we'll record the video as you would on a F-16 gun camera video. The other alternative is to feed this same display with the graphics set up differently into your AR glasses. We'll talk about it in a second. But in MGL, a lot of your nav data comes right out of the serial port. And the Garmin G3X, they don't output very much of anything when it comes to serial data out of their text stream. So what we developed was a little analog digital chip. These are very, very small, cost about $12. You take your 150 millivolt needle output, horizontal and vertical, feed it into the analog chip, output the digital signal, fed into the Raspberry Pi, bring it up in the software, and you have the same type of what you'd want for your vertical DDC and LDC outputs. Works great. And then in the software you can call it up or not have it in there. At the bottom you can see I have a 10 keypad, which is really just a 0 through 9 keypad, and have it set up to do specific functions within the software. So if you press the 1 key when you're flying, it starts a digital data recorder of all the data coming into your HUD. Why you want to do that? Well, if you get back on the ground and you want to replay a certain flight and then fiddle with how your HUD screen design is, you have a little digital data recording of that flight. The second button stops that data recording. Button number 3 will start a traffic display. You can see ADS-B traffic in your traffic display, 360 around your aircraft. You can, in the software, you can set it up how far away you want the traffic. So I normally have it set the traffic that's inside of 5 miles. I only want it to come up on that display. Buttons 4 and 5 drop synthetic buoy targets out in the sky. So the software will drop just a point in the sky that you will then see in your HUD. So you can come around and chase down a synthetic target in the sky. At some point in time, you'll be able to dogfight that target, but right now it's just a buoy out in the sky that you can use. And then button number 6 clears those synthetic buoys out of the database. Button number 7 brings up a series of displays with all the digital data being processed by your Raspberry Pi. And it's amazing the amount of data that little bugger is going through when it's pulling in ADS-B traffic, maybe 100 miles away when you're up in the sky, and then it's digitally figuring out exactly where your aircraft is and then where each of the ADS-B targets are, and doing it in such a way that you can track down. So if you have a wingman and you're trying to look for them, you'll see the N number of whoever you have out there and know exactly where they're at and how to join up with them. So button 8 is a lead computing optical sight control, which is for dogfighting. And there's I have 3 gun funnel modes, which is if you're dogfighting somebody and you don't have target ranging, don't have a lock on the guy in front of you, then it has a gun funnel produces a computing distance relative to a 20 millimeter gun, producing a little lead on the target. You fly it so that the wingspan fits the outside of the gun funnel, and it's set up. There's 3 different wingspans programmed in there, 25, 30, and 35 feet. So depending on who you're chasing, you put their wing tips on the edge of the gun funnel, and it should be a pretty good lead angle for your 20 millimeter in your aircraft. So button number 9 is a flight path marker control, and button number 10 will bring up your ILS displays for a localizer and glide slope. So this is going through how to load a Raspberry Pi and set the SD card up, and I won't say too much about this, but this briefing will be in our website, and there's some other instructions inside of there. But it's pretty simple as long as you follow the instructions. For those of you who have Raspberry Pi experience, you've probably been through this, programming an SD card with the operating system for the little computer. And if you come down to this display afterwards, I can show you kind of the functionality of a Raspberry Pi. They're pretty simple, but they also have a lot of interfaces in there. Quite useful. So this is the latest creation from my son, our TRONVIEW software website at tronview.org. This is designed to let you load our latest generation software and to do it in as easy way as possible. But you just take the text messages that you have on there, have your Raspberry Pi connected into either over Wi-Fi into the internet, and then this will download and install this software into the computer, your Raspberry Pi. You can also use a Macintosh to do this. So this is what the TRONVIEW software looks like. A little icon in the upper left-hand corner. If for some reason you lose control of your display and it crashes, then you can just restart it with the icon in the upper left-hand corner. Like I mentioned, the Gen 2 software comes with the entire HUD display already programmed. You just load it into your computer, bring it up, and run it. And then there's a configuration file that you will tell it exactly what type of G3X or whatever you're using. Now the Gen 3 software you see here is where you design your own HUD display and how you want to interface it with different devices. Again, there's a lot of recorded data files inside of here that you can use as you go through and develop your display. And like I said, the software is free, and it's quite functional. It's a little tedious going through and designing everything. A lot of you just say, hey, I just want to climb in my F-16 and turn on the HUD and away we go. But there will be some default HUD displays inside of there that you can use as is, or you can then take the default one and modify it a little bit as need be. You can see the instructions are circled there in the bottom. E to enter edit mode, put a question mark in to bring up a lot of the questions, and then Q to quit and go back to the primary display. So this is the edit mode. You see boxes around each of the emblems, the text and everything inside of there comes up with a box around it. This allows you to increase or decrease the size of that graphics. You can change the color of it. You can change where it is on the screen, and just about everything you would want to do. The question mark for the help menu, and this is as you scroll through the help menu, when it gets all said and done, you'll see all these different instructions are in there you can use for helping to design your software. And then there's a ruler mode. When you want to center a graphics design in your HUD, know where it is from the center of the screen. So you can hit the ruler mode and it gives you a center point. The little yellow and red around the outside is how you, in your configuration file, you'll tell it how many pixels you have in your display. Now the AR glasses are 1920 by 1080, basically a standard TV type of pixel resolution. The Epic Optics HUD is only 480 pixels wide, about 1,020 pixels wide, which limits a good bit of the about 5 degrees worth of vertical, 5 and 5.5 degrees worth of vertical, and about 12 degrees worth of horizontal display. The AR glasses will give you around 55 degrees worth of visual display out in front of you. So use your mouse pointer for picking different objects and changing the way you want them to look. And so this is where we've been developing our AR or 3D tracking software. You'll pull in ADSP traffic, and then you can define how close you want this traffic to appear, download the FAA database. So everything the FAA has in public domain around any target near you, you can select that ADSP target and see that information. And that's in a 3D space around the aircraft in your AR glasses, and they will help direct you toward where the nearest traffic is. And in the box. Right in the software right now, you see here, every aircraft is a Boeing 707, but that's easily changed. It's just still there in our very early beta software. So now I'm going to go through, any questions about anything up until now? Yes?
So, what would make you choose, say, the camera versus the glasses, or could you do both?
Which would you prefer?
Like, you would put the camera on one side and have that heads-up display, could the passenger use glasses?
Well, the Epic Optics HUD is great in certain ways, but it will not fit in most RVs. You know, an RV-14, an RV-4 has at the most maybe an inch of panel space where the canopy comes down in the front. So it's not even really a question using that in those aircraft. The AR glasses can be used in most any type of aircraft. And so there's a number of folks using the AR glasses now with our software. We don't have head tracking, but all your HUD information is in those glasses. So you could be circling around a point on the ground, looking down there, you'll know exactly where the nose of your airplane's pointed. You'll know what your airspeed is. You'll know whether you're climbing or descending, even though you're looking down at the ground over here on the left side. So it gives you a complete information of what your plane is doing without having to look at anything other than at the ground and what you see in your display. So that's very usable. Would it be better if you had head tracking? Yes. But it's still a tremendous leap forward in situation awareness having that available to you. Okay, some history of HUDs. A lot of great ideas have been presented here at Oshkosh through the years, so I kind of went through as best I could what amounted to archives of what has happened here. So the first thing I found, and some of you may remember this, a gentleman brought a laser display that used the back of your propeller for the HUD. And it worked reasonably well, but it was still somewhat cumbersome. I actually met him this year. He said he sold quite a few of those to a couple South American Air Forces that they put in their trainers. As far as he knows, they're still using them. But left a little to be desired. The next technology I found was a folk called PAT Avionics, which is a laser HUD. They sold that for $6,000, but if you had a dynon, it was $5,000. It had what, in effect, was a real combining glass that you then had to bolt to the front of your airplane, which again limited the types of aircraft you could use it for. And if you didn't have a dynon system, then they had to install their own sensors in your aircraft to pull up whatever information they wanted to be displayed. So as far as I could tell, they were at EAA in 2012 and never came back. So there's no more history in the internet that I can find on PAT Avionics Laser HUD. So the next technology is a company called Aeroglass. It was a combination European and Silicon Valley adventure. They had some early AR glasses they used. Expected production price was $12,000. They had a head tracker, and you can see they had some type of a graphic that you put above your head in the cockpit, and some laser diodes that you put off the side of your AR glasses, which tracked where your head was pointed in the cockpit. They developed several different versions, as best I can tell, of this technology. They still have a website that you can go to, and they talk about how they got to some point in their development, and then the Silicon Valley funding lords decided this was never going to work, stopped funding them. They had a large amount of folks involved in the project, and they had a sad story in their website about how they wish they could go on, but they couldn't. So goodbye. Then in 2017, GRT had a HUD, used a car design HUD called the HUDley. I actually still have some of those. I bought at the end of, that was our first HUD we had, was a HUDley, as we were developing our software. And so when HUDley stopped making these, I bought kind of the last of their inventory, about 8 units. And I still have those if anybody would like to buy one from me. They work fine, but they're limited. Paul Dye has one of the GRT HUDs in his RV8, and once in a while he'll talk about it a little. But using an Android computer that evidently they stopped making, and the GRT software was only good for this one version of the Android computer. And so when the HUDley stopped being produced and the Android computer stopped being produced, they kind of forgot about the HUD world. And then my GoFlight took a version of the HUDley HUD and turned it into a $25,000 HUD. And they developed it to go in business jets. And they had a TSO on it, but the TSO was only for the interface into the airplane. The FAA wouldn't give them a TSO in the HUD itself because it still had a very limited field of view. It only would go to like 9 feet, 8 to 9 feet in front of the airplane is where the focus was out of the HUD. So that's that. My GoFlight, the guy who designed it from MGF had an accident, died, and the other folks in the company decided not to pursue it any further. In fact, one day when I went by a couple of years ago, they tried to sell me what they had left or have me invest in their company. I didn't. I knew better. So right now, HUDs that are in production, the Dual has a HUD which is more like a car HUD again. It's available through Sporties and Aircraft Spruce for right around $500 to $550. The Optics HUD down there is a great HUD, but it's kind of cumbersome, takes up a good bit of space. And then we have the CoSense AR helmet. And I invited Kyle here from CoSense. They have to have a display here at Oshkosh, and I'll let him talk a little about their technology and maybe invite you over to their booth before the end of the show.
Hi everybody. So CoSense AR is mainly a situation awareness helmet. So it gives you opportunity to see the invisible. I mean, it gives you the opportunity to see through a mounted reality helmet, which is head tracked, the surrounding traffic. So just turn your head around and see the traffic around you. There are some circles surrounding traffic and the closing speed of each traffic. And decluttering for having a lower distance of distance detection. So this is our first feature. You can see in this helmet, you see here. And we have other features because our job is to make situation awareness. So the second one is the aircrafts. I mean, when you are in difficulties, you are mainly finding other airports surrounding you. So with our helmet, you just have to turn your head around you and see airports surrounding you like pins on the ground, and you say, okay, just go on that direction because it's the closest one. So it's very helpful in case of emergency, but it's very helpful for comfort also. So even if you don't know the airport you are going on, you just have to fly in the direction, and when you're contacted by the control, they say you, for instance, go on November Echo, and just look around you. You see the beam November echo and just go in the direction of November echo. So it's very intuitive. So the third functionality is the fact that you can download your own flight plan. I mean, if you've got 4 flights, for instance, you can export from 4 flights your flight plan, and then import in the helmet, and then you are guided with some logos in front of you. So you can find the pins which are giving you your points, but also an eagle that can give you the headings and the time of target to reach the target. So it's very helpful, not invasive. Our goal is to have something very low invasive, very thin, so that your situational awareness is correct and you can continue focusing on your piloting. And the last functionality is the traffic zones, traffic area. You know, you're riding close to big cities with a very complex sky. So here we make very simple warning that gives you the remaining time before entering the area. So you've got 3 alarms. The first one is back you are in front of you. You've got not an area, but you can also have alarms for upper area or down area. Well, this is our feature, and we're able to have a very good head tracking, very immune to the aircraft vibration, very immune to the aircraft turn. I mean, if you try to buy a HoloLens, now it's not buyable, but if you try to buy it, and if you try to fly with HoloLens, which is a very famous helmet from Microsoft, with the best head tracking of the world, you put it inside an airplane, and it is completely lost. So it is very, very important to have a good head tracking inside an airplane because of vibration and acceleration. So that's the reason why the guy you have seen before was trying to make some visual detection with some legs and some numbers on the roof. That's because he wanted to be immune to the acceleration of the aircraft. So we have solved this problem. Have you got some questions?
Can we connect it to Microsoft Simulator? Can we connect it to Microsoft Simulator?
Yes, indeed. We've got a link to Microsoft Flight Simulator, and we have got a specific mode that gives you a focus to the screen, so that you need to have a big screen and video projector. Indeed, because you are in augmented reality, so the field of view need to be the same. So you project Microsoft Flight Simulator in front of you, and there is a specific mode that gives you the feeling that you are really flying with the correct field of view. So it's very useful, very true to train on our helmet. I mean, it is important for us to give you the opportunity to train before flying. So even if you haven't got your own simulator, you can go on school, they are simulator, and then you connect to the simulator in the school and have the correct training for the helmet.
They have a display over in Building Charlie. It's 3113 and 3114, I think, in Building Charlie. So they have several. They have their helmet over there, and they have a Microsoft Simulator display that you can visualize how the system works.
Last thing, yes.
Yeah, and we have talked with them already to see if there's some way we can take our software and interface it into their helmet-mounted display. So that's something we'll be working on in the future to see if that works out.
Yes, indeed. We have an inside open API for developers. So this open API is based on internet protocols. So with a Wi-Fi or Bluetooth connection, you can connect to the helmet and then add your own stuff on the field of view of the pilot. So it's a very simple description, but well, it gives you a good idea of what we can do.
When is it going to be available? What's the best estimate?
Yeah, it's still ongoing for the development. We start the production in 2027, And then 1 year later, at the end of 2027, it will be available for buy. But maybe you will have some pre-ordering before. And we're really proud to work with your product.
Yeah.
And I think it could be real good synergy to work together.
Okay.
Thanks a lot.
So next, talk about what we have for display down there are X-Real 2 Pro glasses. These are full color, very high resolution. You'll be totally amazed at how clear the image is on those glasses. The focus for those glasses, as best we can tell, is about 14 feet in front of your eyes, but really you can't tell the difference between because in HUDs, a true HUD, you want it focused at infinity. But 14 feet to infinity is such a small amount, I can't tell the difference. But in the technical specifications, that's how it's outlined. X-Real 1 AR glasses has an IMU chip inside of the glasses. But just like the Microsoft, that chip is not designed for flying in an airplane. It will get lost quickly. But they also are coming out with a little camera, you can see at the bottom here, called the X-Real Eye. That camera is supposed to be able to tell the IMU to be stationary, that whatever you see in front of it will fixate it. So we'll see how that works in these glasses and whether that will help alleviate or teach the IMU how to survive in an airplane, at least somewhat better than the way it does right now. As Kyle mentioned, acceleration and G-forces and stuff in a aircraft take the classic inertial IMU and AR glasses and sends them for a loop. They get lost very quickly. So our TRONVIEW software is set up to work with this technology. The glasses themselves are interesting. They have a Sony OLED display that has somewhere around 4 million pixels inside of there. Each of the pixels has its own lens on it, and that when they create I guess they print the OLED image and then they print a lens on the top of each pixel, and that lens is what allows it to be focused 14 feet in front of your aircraft instead of basically 2 inches in front of your eyeball. Some amazing technology. I don't know, your display probably uses one of these technologies.
We're using combiners. This is the same technology as
okay. See, I have circled up here display B. It's called a bird bath, but anyway, in effect, the OLED display is horizontal at the top of each glass, displays an image down, which is then reflected off of a mirror that's only partially mirrored. So your eyeball can see through the mirror, but the image itself is reflected off of there into the front of the glass where you see the finished image. And the F-35, I think, uses something similar to the bottom right-hand corner where you have a projector somewhere in the back of the helmet that comes around each side and then is put into the lens or the front face of an F-35 helmet is an optical display. It's ground to perfection and is combined with the projector in the back of the helmet to create an image out in the front of you. at the focus of infinity. So each helmet and all the displays are designed and focused just for a single pilot. You can't just give your buddy your helmet and have him run off and use it. It doesn't work that way. And then if your helmet falls off the edge of the jet when you're climbing in, it's a $400,000 accident. So this goes through some of the discussions about what it takes to head track a pilot in 9 degrees field of view. You have yaw, pitch, roll, and you have the IMU chips inside of there, and the computer that tries to add all this together and account for the acceleration factors that aircraft present that folks sitting in your chair on the ground don't see. So this discussion here, I'd asked ChatGPT, given a 9 degrees of freedom, so to draw a picture of the forces acting on a pilot in an aircraft looking straight ahead in a right-hand turn. And ChatGPT got the description's pretty good, but when it drew this image of the pilot's head, it actually had the x-axis coming out the top of his helmet going straight up, and the z-axis coming out of the same helmet going straight down. Well, it doesn't work that way. I then spent about half an hour trying to get ChatGPT to take the x-axis and come out the pilot's nose, and it never quite got it right. So I gave up and finished drawing the image myself. But anyway, this is a complicated factor, as Kyle knows, doing head tracking in an aircraft, and which is why the F-35 helmet ends up costing $400,000. And that's just the helmet. That's not the aircraft interfaces that go with it to make the helmet work right. So this is one of the IMU chips that we've been playing with. It's called the B&O 085. It's a 9 DOF. It has a pitch, roll, yaw, and a magnetometer inside of the chip. It's amazing technology. But it wasn't designed for an airplane, so it takes a lot of additional inputs to make it work right. This is for discussion. The AR glasses with with your headset on. The AR glasses are thin. They're not perfectly thin, but they're small enough that any type of reasonable headset will fit over it. The video is fed by a HDMI-C connector and comes out the back left rear temple of the AR glasses. A lot of the other glasses we had looked at and played with, the interface into the glasses is on the side, or there's big bulges, or they try to put batteries inside the glasses, which takes up the bulk and adds weight and serves no useful purpose in an aircraft. So, which is why we settled on the X-Rail. There may be other glasses that work. If you, we don't limit the use of any one type of glasses in our display, but we know these work. So this is some views of the software of what you can see out of the HUD. This pitch, roll, yaw, indicated airspeed, true airspeed, G's, the outside air temperature, the wind factors, and I have waypoint distance down there that you can display for the next waypoint you have in the aircraft. RPM, if you can get that out of your computer, you can see what your current RPM is, local time. I say radar altitude up there. It's actually just altitude above the terrain. With Garmin G3X, you can get radar altitude out. And then your regular altitude. This is what the localizer glide slope needles look like. And this is if you're doing just a functional test, what you would see. This picture here is from the little gun camera that I have on my RV8 Epic Optics HUD. So when we're done here, we should have time. I'll play you a video that I took of some guns tracking. So this is a really nice rendition of the accuracy that you need in a head tracker, so the 3D world winds up being accurately displayed in your helmet or your display goggles. So the bottom picture is 1.3 degree accuracy, and you can see where the runway ends up at versus where you can actually see the runway. And the top is with a 0.1 degree accuracy, how close the visual display is versus where the actual runway is. And I don't know, Kyle, what's the specs in your display that you're aiming for?
Yeah, we are under 1 degree, so we are not really able to make adjustments on the runway. So it's around 1 degree.
So around 1 degree, and that's pretty good. It's not easy to get to 1 degree. So this is what the Epic Optics HUD looks like in a standard RV8 canopy. One of my neighbors has his HUD installed with the buttons, the tin keypad you can see underneath the bottom. And this is what the software architecture looks like that my son wanted included in here, since he's the guru behind the whole software. But the beauty of it is that each different ethos or display that you're putting inside of there for pulling the data out of, you'll pull the data out of, and when you then give it a common name, which the software will always use. And so you pull out something, let's say, we'll call it radar altitude. But in the software itself, when you pull that data bit out, it is then given a common name. So no matter who has it or what screen is being used, if that data is available, you don't have to figure out what a G3X is calling it versus what a Dynon is calling it. It's just a single name that is in there, which allows you to then create the software and the HUD design software that you just call up a function of what you want displayed, and you don't have to worry about what it's deep in the software, what the data is called. You just want a altimeter display there in the way it is, and then you can decide whether you want it in meters or in feet or whatever, parsecs. And this is a simple schematic design for an analog to digital chip and a RS-232 to TTL interface into the Raspberry Pi. And the newer software, you can then just take a USB plug that has an a serial interface on the other end. So you don't have to even create your own chip. It's all done internally. If you can wire it to a DB9 connector, then it will be interfaced into the Pi. So, any questions? So let's see here. I will try to go back and okay, this is my gun camera HUD picture. The audio's not making it out, but anyway, you can hear our AOA tone is actually in the background in a turn here. That's what a gun funnel looks like. And the little dots represent a specific range with the wingspan inside of there. And it's kind of, this vibration is causing the focus to be out a little. At some point in time, at different power settings, it'll be a pretty clear picture. Other times it'll get pretty bad. It's interesting, the audio was here on Monday and today it's not here, so. Making 360 circles on a sunny day, and you can still see the HUD image. But that's really what you want. And you can see different colors on here. Yellow comes through good, green comes through good, and white comes through pretty good. There it gets really clear for a second. The ADSB ranging is amazing when you think about the fact that what the little Raspberry Pi, this was with a Raspberry Pi 4 computer. So it was down to about 15 frames per second with the software in a Raspberry Pi 4. The Raspberry Pi 5 is about 25 to 30 frames per second. I know most of you care less about dogfighting your neighbor, but if you have an RV8, it does occur to you every now and then. Okay, that's it. Any other last questions?
Is there anything specific to the Raspberry Pi besides like GPIO, or could you use any board with GPIO capability?
With our software, you can use any board our software would be compatible with. It's also called an orange raspberry, or I don't know, something like that. We haven't tried it, but we think it might be fairly compatible with that.
Okay.
And the Raspberry Pi has Ethernet, 4 USB connections, has I2C, which is another interface that's in there, and then it has serial and TTL. So many different ways to interface into that little device, and it costs anywhere from about $80 to $100. So when you add all that up, it comes to be a pretty phenomenal little technology. Any other questions? Yes.
What limits use in certified airplanes? I think you said your son used it in a mall.
In the mall, it's not integrated into the aircraft system. In the mall, the eye-level bomb, and the eye-level has a booth here. I don't know, are you with eye-level, or you just have one of their shirts? You have one of their shirts?
They're in Banner C.
Okay, in hangar C?
307.
Yeah, so the eye level has a bunch of different devices that you can put on your airplane, and most of them don't require you can put it on a commercial or production airplane. And then they have Wi-Fi that comes out of the eye level and feed it into the Raspberry Pi, and we have the software interface in there to pull the Wi-Fi out. And the same with the Stratix. The little Stratix box has ADS-B, and some versions also have a very simple attitude indicator in there, and it'll output GPS ground track. The eye level, I think at least some of them will give you real indicated airspeed versus just GPS ground speed. So then in the aircraft, you just take 12 volts, turn it into 5 volts, feed it into Raspberry Pi, and then interface out of the Raspberry Pi into the AR glasses. Any other questions? Well, you're welcome to come down to our display down there and get a little hands-on about how what the AR glasses look like and see what the Epic Optics HUD looks like. Thank you.
Thank you.